Welcome to our series on quantum computing. I'm Andrew Mitchell, Managing Partner at MNA Due Diligence Solutions. And today, Gary Jackson is joining us to talk about quantum. Hey, Gary, thanks for
Hey,
joining us today.
hey, thanks, man. I really appreciate it, Andrew. And by the way, I'm in the U.S., so it's cold. Where you are is warm. So we're entangled though by the weather, I guess, is what I'm trying to say here. So as it gets colder here, I guess it's entanglement that it's making you hotter down there. Horrible transition to talk about quantum, but just wanted to throw it out there.
But it's all part of the deal, isn't it?
It is. It is.
Yeah. Gary, just to start off, tell us how you fit into quantum and why it's interesting for you.
Yeah. You know what's funny? My background has been in data science, analytics. I taught data science, and then now into AI, machine learning back in the day, neural nets. But one of the things that really was fascinating to me about there was a newer technology that actually about 5 to 6 years ago was technically theory. It was quantum computing. I do not have a quantum mechanics background. I only wish. And when I do get down into the deep details of quantum mechanics and stuff, it really does go over my head. But what was fascinating to me about quantum computing is there was always that saying that said, "Find a needle in a haystack," and that's what quantum is. It can find out really finite details. When I lived in Hong Kong, there was an idea that I always had is, will analytics ever get to the place where it can actually predict what taxi is going to pick you up at what time anywhere in the city of Hong Kong? Where do taxis go? Is that just random? Can it be predicted? And that's where quantum can fit. Quantum can determine something to a finite, really focused detail, and that was what was really exciting about that. And I work in casinos. I do a lot of work with casinos. I do a lot of work with banks, healthcare. And what was also interesting about the quantum computing piece, which is the impending doom, I put that in quotes, around passwords being blown away because quantum computing will be able to figure out passwords or break into your digital wallets if you're with your blockchain and that type of thing. So those things started pushing me in that direction. And so we're still, we started the investigation, started working on the path towards modernization. And that's kind of where I am right now.
Tremendous, thanks.
Yeah,
So let's get into that. Let's get
sure.
into that haystack then.
Okay.
Um, what is quantum computing in relatively simple terms?
Yeah, well, I'm going to talk about it like I'm Forrest Gump, like the movie from 1992. By the way, that movie's way so. I need to get a newer reference. But anyway, I'm going to talk about it in very simple terms. Everything that we deal with right now, this video broadcast that we're watching right now is all zeros and ones. Lots and lots of zeros and ones, on and offs, on and offs. And basically, those are translated over time to be able to, and aggregated to be able to create this video screen that we're seeing. Quantum works a little different. It's not zeros and ones. It's basically being able to transfer information on atoms, and atoms being kind of put together. And what I think of them is kind of like lottery balls, because in zeros and ones you only can keep on and off information. With quantum, these atoms can be called qubits, and you can keep a lot of information on them, and you can move them in different positions. They actually can be on and off at the exact same time, which is kind of blows your mind. And because of that amount of information that can be kept on a qubit and be able to be passed, that really puts us in a whole different perspective of how we can do things, how we can compute things, how we can be able to determine stuff. So these qubits, they're like spinning a coin. They're basically heads and tails at the exact same time. And because it has multiple states at once, a quantum computer it doesn't just try one path. It doesn't figure out one way and just go all the way to the end and say, "Oh, that didn't work. I couldn't find the cheese. Then I'm gonna go through this maze and try to find the cheese." It goes in all different directions all at one time to be able to find something. And that's kind of the basics of what quantum computing can do
So all those paths at one time. That sounds
at one time.
massive.
Yes.
Yeah.
It
So
sounds like
what
someone's
will?
sounds like someone's smoking drugs. You know what I mean? Because
Yeah.
it sounds like, or you're watching a Marvel movie. By the way, when we say quantum computing, it's not quantum mania like we see in Marvel. They created a whole nother world, so it's not the same.
Yeah. So what will it do better for us then if it can do all those paths at once?
Well, the things that it's doing now, and by the way, too, we're really very much in its infancy stage. It's just started. Quantum computing has really kind of began because, like I said, 5 to 6 years ago, it was just theory. Now we physically have a box that is about the size of 2 refrigerators that we can bolt into a data center, and it actually can do quantum work. And what it really focuses on is what it's really good is being able to do. I'm going to lay out some of the basic ones: drug discovery, logistics, finance, being able to determine like a perfect investment portfolio. Material science, though, is where we're really seeing a lot of benefit right now, creating new materials that never have been thought of before in different combinations. And so, and also the drug discovery piece has been really good in the pharma. There's a lot of pharmaceutical companies right now that are doubling down on that. And I'm also doing some work with insurance companies. They're basically using quantum for, because COVID broke all of our actuarial tables. I mean, it just kind of screwed everything up. So the underwriting is messed up. So they're starting to look at quantum computing because it's, to look at every possible outcome for actuarials and underwriting. So those are where we're seeing quantum actually really making a difference.
Yeah, so it's being able to look deeper into things we haven't been able to look at
That's correct.
before.
And in multiple ways.
Yeah, yeah. So you mentioned that they're the size of refrigerator. When
Yeah.
will it really get here to be usable?
So there's two types. Well, there's multiple types, but the two, as me being a basic layman looking and diving into quantum, there's room temperature quantum, and then there's absolute zero quantum. And what that means is keeping. IBM has a machine that basically has to be kept at absolute zero. And the reason why they have to be kept at absolute zero is because when you're putting atoms together, they're almost like they really literally are. It's hard to keep the atoms kind of stacked together. I'm saying that in the wrong way. And when you can't keep those atoms kind of packed together, qubits, it creates a lot of errors. And so IBM's way to get around those errors is absolute zero. However, there's a couple of other vendors that are out there, Quantanium, IonQ, that has something called room temperature quantum. And this room temperature quantum does look like 2 refrigerators kind of packed together. The IBM one is kind of like the old mainframe. It takes up the entire room, and that's the absolute zero. But the quantum room temperature is about 2 refrigerators, and the problem, though, as you probably can guess, is there is a lot of errors that happen because it's room temperature. But what's great about that is it takes very little energy to be able to keep a room temperature quantum computer working as opposed to an absolute zero one. So those are the two. How soon will it get here? It's already here. We're looking at, like, without errors, we can get up to probably 50. Some are saying 100 qubits together without, and they're running models over those qubits to correct for errors, so they can actually get some computation time. And they're doing some amazing things with it. But again, it's very finite, very, very focused. So it's here. But what we're looking at is getting it from 100 qubits to 1,000 qubits. What we believe is that once we get to that 1,000 qubits, then you're going to see an exponential growth from 1,000 qubits to 10,000 qubits to 1 million qubits. It will, we'll be using quantum to figure out quantum, and that's going to be a really, really interesting time.
That will be.
Yeah.
So if one of our viewers today wanted to engage with it straight away,
Yeah.
what could they do? Could they rent it? Do they need to build one for themselves? What's the status?
What can they do? Yeah, there's a great company out there called Qbraid. Qbraid is basically a quantum computing company for hire. And what they do is basically think of it as an AWS or Azure, but for only quantum computing. And they offer every quantum computer that's out there. They also offer the PhD quantum mechanics students that are in PhD years that are basically, they can kind of hold your hand and walk you through that. So they give you the opportunity where you can actually test out each quantum computer without having to go out and spend $10 million to buy a quantum computer. However, you can buy one. You can go and buy one right now. You're looking at a minimal investment of $10 million. But the beauty of it is that there's so much demand for quantum computing. If you did buy, and we're seeing this with some of the casinos and some of the banks, they're buying quantum computers, and when they're idle, probably half their time. So they're not actually being used 24/7. So on their idle time, they're actually selling that service back to a company like QBraid or, for example, AWS or Azure. They also offer some of this quantum computing for hire, and at a at $5,000 per wall hour, you're getting money back. So what that means is if you did buy a $10 million quantum computer, you're using it only 50% of the time. The other 50% of the time, you're selling the services back. You could pay for this quantum computer in less than 1 year. So it would pay for itself with that. So that's what we're actually seeing, and that's where you can actually go out and use it. AWS has one, but they're using, but the hardware is all about the same. It's just the interface you want to use it, and they also have built out a coding languages that you can actually code and be able to connect to quantum computing too. That's a whole ecosystem to itself.
Yeah. So there's full rental options, there's supported rental options, and it's already here.
Yep.
That's amazing.
Yes.
So with all these new good things, there's often risks that come along. You mentioned some security concerns before. What's all that about? What is Q Day?
Yeah, so Q Day is the day that basically quantum kind of unravels all passwords that we know. And how could it do that? Well, every password that we know about as humans is linked to something. Either it's and when we say random number generator, it's not really random. It's based on some code mechanism that maybe the developer who created that random number generator based it off his child's birth date. Or and you as your passwords. Think about your passwords that you have right now, and is it your wife's name or a significant birthday or your pet's name? So everything's linked to that. With quantum is going to be able to figure that out and unravel that and break it open. And one of the scenarios that I was told, which was kind of frightening, is in about some say 5 to 10 years, some say 3 to 5 years, but one day you will be going to get gas, or you're going to recharge your electric vehicle. And when you go to pay for that charge, for some reason your card doesn't work. And you're like, okay, no problem, let me get another card. That card doesn't work. You're like, well, crap. And then you use your credit card. That card doesn't work. Then you go and then you see other people around you having the same issues. Then you go into the ATM that's inside to pay the fee, but then there's no money in your account. And then things start unraveling from there. That's a worst case scenario, but that's a very frightening aspect. And what's going to happen with that is it's not all going to be at once. It'll be happening little. They'll be taking chunks of information all along, and then all of a sudden, when it might be too late, they'll realize that passwords have been decrypted, and now they're already in those systems, and they can't, and we can't get them out. And that's where Q Day is. So Q Day is probably not going to be one day. It's going to be a slow build up to say, holy crap, passwords don't work. And so what we're building out is how do we help build servers that don't use the common encryption that we use for passwords and security that we have now, but it uses quantum key distribution. It uses quantum kind of encryption. And that's what we're trying to transition banks into, insurance companies. And what I would say is any company that you're starting to work with, or if on the technology side, there should be a skunkworks project to look at quantum computing to prepare for that day. I think Y2K in '99 was a scary proposition with that, the COBOL 2 zeros for the year. I think this is probably times 100 worse, or times 1,000 worse, when everything can be. But there's not all doom and gloom. There's ways around that. There's quantum key distribution, getting that set up. We're also looking at different ways to do passwords. Eyes can be plucked out, fingers can be cut off, faces can be Xeroxed or copied, but we're using heartbeat authentication to get people to be able to log in. So you're going to start to see a lot of transition, and you hope that banks and insurance companies and casinos have a little skunkworks project in their IT team looking at these type of technologies to prepare for that Q Day, whenever that might happen in 3 to 5 years or 5 to 10 years.
Yeah, there's certainly a lot in that, and I can fully understand why people are going to be pretty alarmed by it.
Yeah.
It's good to know that there are devices coming out and research is going into, well, how do we fix it before it
That's
actually
right.
happens? Yeah.
That's right.
And then while we were talking about it previously, you also mentioned harvest now, decrypt later type
Yep.
concerns as well.
Yes. Yeah, and what that actually means is they're gathering your data now. They may not be able to read it, they may not be able to crack the code to be able to look at that information, but they're harvesting. They're basically collecting all of this information with your passwords, your data that's being passed along. And what they're going to do is once they can crack it, once the Q day happens, being able to go back in time and be able to do trending. There'll be a whole analytics team, basically criminal analytics teams doing, BI reporting on you, map of you, what you did, what you've been doing, and then forecasting on what you could do. So it's going to be a really interesting scenario when, for example, you're trying to change your passwords or you're trying to change your behavior, but at every step to try to change your behavior, the criminal's still there. So it's going to be really fascinating how that's going to transpire. I think it's a scenario we haven't really thought out. Once they know what your past is and they know your present, and they're using quantum computing, what if they know your future? And so, because you're being very focused, if they can figure out drug discoveries or material science, they can figure out what you might do next. So that's why I do make a joke of my classes when I teach is be very human. What I mean is, it's cool to be random. Go and be, sometimes just, for example, one of my classes, I'll teach a class and I'll just run out of the room randomly. And everyone's like, whoa, that was weird. I'm like, well, if you look at the behavior, I've taught this class 5 times. Every time I teach that class, on the second day, I always run out of the room to show how. So it's not really random. It's just a predicted thing. So how do you change your behavior that is truly random so you can kind of protect yourself? And that's going to be a
Yes.
really interesting when Q Day starts happening.
So we've got license to be fully unique.
Yes. By the way, when we keep saying that AI is going to take over the world, I think we should go the opposite way too. Is we should be more human than ever. Be as unique and unpredictable as that's going to be the new motto. Be most unpredictable. Actually,
Okay.
I just quoted myself. That was my name in the school yearbook. Most
Very good.
unpredictable. Yeah,
But
yeah. So
I do think that there's a full discussion around the relationship of AI and humanity,
yep.
and if we get that balance right, there's a really interesting story there. But yeah, if we get back on the topic here with quantum,
Yeah.
and we think about building values in a company and what you've talked about quantum can do and what it's going to be really good at, it's not
Yes.
going to do everything. It's not going to replace AI.
Nope.
It's going to do some things really well. So
Yes.
if you consider it in terms of building value in a company, what do you think those things would be looking
Yes.
forward?
Well, I use this example to explain how all these technologies come together. So if we see a upside down triangle, um, if you can think of the food pyramid that we grew up with, that we knew about when we were kids, showing the foods we're supposed to eat, which was kind of flawed. But anyway, it's upside down triangle. At the top, you're looking at data warehouses, databases, the stuff that we started off with, and then from that's that top layer. That's what we had to start off with, and then from there we went to BI, business intelligence and reporting, and that type of thing, and then we went into big data aspects, and then we started doing analytics and forecasting and predict. But see, we're getting down to that little point at the bottom, and we have the AI slice, and then we have those, but that very finite point at the bottom is where quantum fits. And quantum is about really finding the needle in a haystack. And I'll give you a case in point. A lot of people, they're still trying to literally wrap their head around how does quantum work and why should I be concerned about it. Well, the greatest quantum computer, I should have answered this earlier when you said, hey, can you use quantum now? Yes, you can use quantum now, because the greatest quantum computer is your brain. Your brain right now, if you're listening to me, you're listening to the words coming out of my mouth. You're probably reading an email at the same time or writing an email. You're doing all these different states all the exact same time. Thinking about the kids. Think about I'm going to be what you're going to be doing for the holidays. All these different states are all happening in one time. And then think about what you did, the energy you put into your body to do those things. If I created AI chatbots to do this interview that we're doing, it would take up the entire power grid of the city that I'm in right now, or even maybe the state. just to have two AI chatbots having a conversation that is, that seems kind of impromptu. But with quantum, keeping all those different states, actually, all I need is the energy of a light bulb, 35, basically 35 watts, kilowatts. And what's really interesting about that is that being able to, and as a human being, whatever food you ate, I just had a salad. And that energy has sustained all these different states. So you can see and think about the things you do in your brain. You start focusing on really finite details. You start getting into the weeds of things. The big picture pieces, you have a file cabinet to keep that. You have a computer to keep your spreadsheets. But when you want to really come up with a decision or make up a really creative decision process, that's where your brain comes in, and that's where the quantum computing piece comes in. So those are the things that I see as we're trying to explain what quantum can do and how it's going to impact us, how it can all link together. And I think that's a very powerful, kind of a powerful metaphor to get it across.
Yeah. So within a company, then we think about research and development. So that potentially research and development and product development can get a lot faster.
Yep.
With the number of simulations you can do. So you'd
That's
expect
correct.
to see R&D cycles just drop from years to months, maybe weeks even, if
Right.
we got really good at it.
Well, if you see the computations that usually would take 10,000 years now are being done within 1 hour, and that's huge. 10,000 years, not days, not months, years. Anyway.
Yeah, and we touched on AI previously. How do you see that relationship between quantum and AI? How is it going to make that world better for us?
Yeah, so there's going to be what we call hybrid computing, where you basically have classical computing, which is your zeros and ones, and you have quantum computing, which is what we were talking about with the qubits. There's going to be a mashup because AI is very good at being able to feed in. I always call AI as basically a photographic memory. You're basically loading in all of these different patterns of pre-existing situations, and it's looking for the best way to answer a question. Or if you've ever seen someone try to read your lips and try to predict the next word you're going to say, that's really what AI does. Quantum thinks about every word that you are going to say at every moment, and I'm about to sound crazy, in every universe. So one of the things when I talked to one of the CTOs of one of the quantum computing companies that we partner with, when I met with him, he explained, he said, when a quantum computing networks together and you get another quantum computer to network with another quantum computer, and it really gets to a place where there's less errors and it's really connected and information is entangled, and we're going to get to that too. There's no upload, download that's entangled. Your quantum computer, that quantum computer is connected to that quantum computer and connected to every quantum computer ever created and ever will be created in every universe. That is mind-blowing. Where AI is, I'm just going to load in all this information that I have, throw it into memory, have a network map it out when a question arises, and feed a lot of energy, water, and power resources to retrieve that information. So it's very different in concept. And when I get into the whole multi-universe thing, again, I'm not talking Marvel. That's where quantum mechanics, and that's where quantum computing becomes just a big black box that I'm connecting to and get results from.
Yeah. So AI might be able to do a process, interact with people, but quantum will sit there and run through every permutation of every possible solution to something and could potentially feed that in to the AI process.
Yeah. I mean, you could be able to see, things you could predict. For example, the financial crisis, you could probably predict with, I'm generalizing, with AI, because there were certain factors, there's data points, but predicting September 11th or COVID, which are really random events that happened, that's where quantum could come in. Again, I'm generalizing a lot, but just to kind of give the examples of what one is good at and one is not.
So is there anything else we need to know to summarize what we've talked about?
Yes. I would say one of the things to remember for this is it is not, you can't just go to universities and pluck, data science student and because I'm learning this myself, and get them into quantum computing. It's a whole different type of people you have to recruit. And these people are not cheap. I think that over time, as things get a little bit more commoditized, it might be cheaper. But to hire a PhD to come on board to do your work, you're going to spend a little bit of money. And then the other thing to know is a quantum computer cannot stay online 24/7. You can't have an 100% uptime. It's just like your brain. Your brain has to sleep. And the quantum computer right now also has to sleep, and it has to be cleaned and rebooted and restarted. So it's not a continuous process. So things to think about that's different than your classical computing is there's investment, but being ahead of the curve and going in that direction, and knowing that China, Australia, Canada, U.S., Europe, they're all in this race to who's going to build whose quantum computer is going to be able to have 1,000 qubits to 10,000 qubits first. And when we say 100 qubits, that's the entire internet on 100 qubits. Just imagine the type of information with 1,000 qubits. And again, I'm generalizing there. But the things to remember is this is not a small undertaking, but I think it's definitely a necessary one.
Yeah, absolutely. You think of those almost like the space race.
It is.
It's an endeavor that's going on, but there's far more countries involved, far more companies involved this time, and they're progressing very, very quickly,
That's right.
relatively.
And think
Yeah.
about this too. I mean, with AI, we can find out what we've already done and predict the next word. But with quantum, I can figure out what is the energy source that makes the sun never-ending energy. So you know what I'm saying? So quantum would be able to maybe lead down discoveries to be able to uncover that, or anti-gravity. You get what I'm saying? So we really quantum leap, like the TV show, into a whole nother dimension of, space travel, mineral mining, asteroids. I mean, and also quantum money. If blockchain goes to zero, or I'm sorry, Bitcoin goes to zero because they're the digital wallets, quantum money will be another source. And the difference with quantum money as opposed to Bitcoin money is quantum money would be entangled. There is no transfer of money. I just say you can have it's just there, and it can go across vast distances, even across the universe, like that. So you're seeing a whole nother world that we're either going to blow ourselves up before that time, or we're about to really. I think the children of now are going to see significant technology changes that we can't even fathom.
Indeed, I think that's right. The scale of the change, the concept of the change is huge.
It's vast.
Well, yeah. Thanks very much, Gary. Certainly appreciate you taking some time to guide us through the haystack today and teach us all a bit more about quantum. Look forward to talking to you again in the very near future. There's many things here for us to unpick, I think.
I agree. And thanks so much, Andrew. Looking forward to doing some more work with you as well.
Tremendous. Take care, Gary.
Ciao.